I can go ahead and put this in slideshow mode. I made some changes to some slides this morning, but I didn't have time to animate them. So there may be some things that are out of order animation wise on what I added. Here's our first objective: write terms of a sequence from the nth term. Now you're thinking, what the heck is the nth term? Well, first of all, I want you to get out, I'm not sure what page it is in your folder. This is the bottom half of it. It's pretty much to the back. It's a handwritten page in total. 30. Okay, page 30. If you turn to page 30, and there's something that you need to add to your page 30. There we go. Now I've got page 30. And by the way, what we're going to add on page 30, you also should add right here on page 32, where it says the nth term of an arithmetic sequence is given by a to the n equals a to the 1 plus n minus 1 times d. You need to add that both places. This is an alternative variation of that if you don't know the first term. You use this one if you don't know the first term. And it'll take you quite a bit of work, actually. Okay, everybody got those two changes made on both pages? And by the way, that page 31 and 32 are fundamentally every formula that we've used in this course. Kind of a complete list. So let's continue. These are just some definitions. I don't know that you need to write them down. What this means right here is it's a set of numbers in order, in some kind of an order, okay? And based on that order, you can predict the next one based on some rule. And that's where we're headed. Now we've got infinite sequences, which keep on going forever, means they end somewhere. Means they go on in the same pattern forever. Now, this is starting to be kind of important. Here are the terms of a sequence. If I gave you 3, 5, 7, 9, 11, 13, and so on, the 3 dots means and continues this way forever, is what these 3 dots at the end mean. And continues this way. But here, when I say this is 3, that's 5, that's 7, 9, 11, 13, then what I'm saying is your first term, these subscripts just denote what term in the sequence, the order place, if you want. Okay, that might be a good way to word it. I just made that up. Okay, the place in the order is what these terms mean. And that's the general way that we write sequences. Okay. Now, if we've got this, the nth term is the last term in your group. Okay? That's the total number of terms, or that's the last term. Now, in this case, we're saying the value of this is equal to whatever how many terms there are squared plus 5. That is a rule associated with this. Okay. Now, in this case, first square one for the first term, the value of the first term is going to be 1 squared plus the 5 gives you 6. So that means in this particular sequence, our first term is going to be 6. Then the second term will be 2 squared, the place of the term, plus 5, or 9. So now we've got 6 and 9, and 14, and 21, and so on. And we can graph this function. Here are the individual values, okay? If n is 1, then we had 6. If n is 2, we had 9, 14, 21 respectively in the curve. So we can graph these. That looks very much like an exponential curve, doesn't it? Of some kind. Okay, here's another one. Here's our rule. Here's that first term. So the value of the first term is going to be 3 times negative 1/3 to the first power. Well, 3 times negative 1/3 is negative 1. Because anything the first power is itself. If n is 2, the second term, the value for the second term then is the rule. So we have to square this first, which is going to make this positive 1/9. And then 3 times 1/9 simplifies to a third. You might want to put in that extra step I told you. Okay, now for the third term, the value of the third term will be this business to that. Well, negative 1/3 to the third is negative 1/27. They're not going to show that, but you might want to. Negative 1/27. And then 3 times 1/27 reduces to negative 1/9. The fourth term, we're going to get an even value again this time. We're going to get an even value because a negative to the power is positive, just like it was over here to the second power. So we get positive 1/27. Now, negative 1/3 to the fourth is positive 1/81 if you want to put it in. Now then, negative, positive, negative, positive. This is an alternating sequence. Okay. Why is it an alternating sequence? Because of that negative multiply the rule. That negative to a power. And that's typically how you'll get an alternating sequence. Ta-da. Any questions before I go on? All right, now, Again, here, this is just more elaboration about alternating sequence. Anytime you have a negative to a power, you're going to get an alternating sequence, is basically all this is saying. Now, if you had something like this, then your alternating would be backwards compared to that one. Because 2 would become 3, 3 would become 4, and so on. Here's another one that'll also give you an alternating sequence. Okay, let's look at these two. Here's my rule. So what do I do then? I put the 1 in here, 2 times the first term, plus 3 gives me 5. 2 times the second term plus 3 is 7. 2 times the third term, 2 times the fourth term, and here goes my sequence. This appears to be that sequence that I described to you right at the beginning, doesn't it? The set of odd numbers. Well, what if we replace that with just 2 to the n plus 1? Would that give you the same answers? I mean, just n plus 1. 1 plus 1 is 2. 2 plus 1 is 3. Nope, that wouldn't work. You can come up with others, so other variations. Here, we're going to have alternate. We can predict an alternating sequence here. So if n is 1, the first term, we got that, times 1 squared is -1. Second term, we got a +1 times 4 is 4. Third time, we get a -1 times 9 is -9. Fourth term, we get a +1 times 16 is 16. Okay, questions before I go on? Anyone not ready yet? Okay. Fortunately, we don't have to do recursive. That's when one term builds another term. They drop that from our objective. Okay, now we're just learning a unique, discrete, meaning separate, fact. It's called factorial notation. Any of you ever heard of factorial notation before? Sound familiar to you? Yeah, I see a few heads nodding. Okay. Well, factorial notation is a number built on itself. For example, 5 factorial means the biggest number times the next one down, times the next one down, times the next one down, times when you finally get to 1, and all of these equal 120. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. Okay. If we had 6 factorial, then we'd have to take 120 times 6 out here and get an answer of 720. Because 6 times 12 is 720. Okay. So that's how factorials work. Now there is a definition I need to give you. 0 factorial is 1. 0 factorial is 1. Now, here's the rule on this thing. To get n factorial, you take the nth term times n minus 1 times n minus 2 times n minus 3. 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 3 is 2, and so on. I mean, that's the algebra of this. But hopefully you understand just that you have to multiply them all down sequence. And here, I told you that 0 factorial is equal to 1. And so is 1 factorial. So, well, we did that one already. It's 120. You do this one. I threw a division in there on you. Now, before you start it, you can do it the easy way or you can do it the rough way. To use Tina Turner's words in the song Rolling on the River. You can do it easy or you can do it rough. Oh my, it looks like all of you are doing it the hard way. You're going to groan when you see this. $30. All these cancel out. It's just 30. 5 times 6. Like I said, there's the easy way or you can do it rough. Maybe that was kind of cheap, wasn't it? Okay, let's look at this one. Okay, what do we got here? Everything from 5 on back cancels. But I've still got the 4 factorial and the top end of the 9. So now we got 3 times 1 times 7 is 21. Times 6 times 21 is what, 126? And we've canceled out all of those. Now, do you have to cancel this way? No, but you can. And save your, I mean, doing this canceling is easier than multiplying 9 times 8 is 72 times 6 is I don't know what. I don't know what. and then long dividing it by 4 times 3 is 12 times 2 is 24. That's fine. And which just left the top end of that. And you still got this 4 to contend with. Okay. Any other questions on this one? Okay. You know, if you can take these shortcuts, that's faster than putting it in your calculator. Oh, by the way, you have a factorial key on your calculator. In case you've never bothered to notice. Okay, let me pull up my calculator. Let's put in a fraction here, and 9, somewhere I've got a factorial key if I look close enough. Right up here, see this inverse key has an x factorial on it. So I got to shift and then hit it. And then I go down. And in this case, I'm going to put in 5, shift, factorial key, times, what's my other one? 4, shift, factorial key, and get out of that. Like I said, it's faster to do it this way than it is to put it in the calculator. But you can. And now you learned where your factorial key is. Oh, man. I erased all my slide. There we go. Let's do this one. After we spent a whole bunch of time on this one. This one is an algebraic one. The answer, believe it or not, is very easy on this one. Or 9. Okay. If n were 9, I would have 9 factorial over 8 factorial. Is what that represents. Well, this 8 is going to wipe out everything except the 9 itself. So it would be, in this case, 9, or simply n, the top term. Now, anyone not understand what I just said? Or need me to go over it maybe another way? Okay. Here are a couple more. We're going to skip over those. Let's go to this. Here's my any number in the sequence. Here's my rule. So if I want to find Okay, if I want to find the third term, I would replace that in with a 3. I replace that in with a 3, and I would replace that in with a 3. Like that. Now we need to simplify this a little bit. 3 times 3 is 9. So we've got 9 factorial. 3 times 3 is 27. So we've got 9 factorial over 27. Now, they gave you that number, which simplifies to that. Now, let's try to make this as easy as possible, okay? Agreed? But you still got to multiply out all those. And presumably, well, it wouldn't relate to either one of these two numbers, but presumably, if you did multiply all that out and you did this and you did this long division, you would get that, or we could go in here and put, let's see. Yeah, here we go. We're finding a to the third. I would probably do this far on paper no matter what, because putting that in is going to be a pain. So I would probably just do fraction 9, shift factorial key, go down and put in 3 squared, or cubed rather, row 3, and get out of it and hit that. Okay. Now, what does Mr. Carter and whoever's grading your final, whether it's me or someone else, and I need to talk about this further, but I'll do it not today, in terms of how the finals may be graded. But in this case, as you look over here, what I see as a minimum work on this problem for partial kind of work is, well, or you can have 3 to the third right there, I don't care. In other words, basically what I put in the calculator. And remember to use your calculator on the final. And chances are you may not need to. I mean, usually it's possible to work every problem, even the logarithm ones, without a calculator. But it's easier with it. If you put it in your calculator, put what you put in your calculator on your paper. Okay. Very important. Very important. I'll put this up there, let you read that. The only difference in this, okay, is now instead of treating these as discrete terms, now we are adding them. Okay, in this case, we are adding the terms instead of them just being discrete terms. Now, presumably, this sequence would go on forever. But we're going to pick some end point arbitrarily. And then we call, if we pick an end point, then we call it a finite series. Just like before, we called it a finite sequence. If you got those pluses, it's a series. If you just got the commas where they're discrete values, they're a sequence. It's a matter of language, okay? This letter right here, sigma, means we are going to find the sum of all the terms in this, is what this term means. You see sigma, you think find the sum of all the terms from whatever your first one is to whatever your last one is. And that's called a limit. And we'll talk more about that a little later. Okay. And with this, we're going to stop for today. This will be my first slide up on Wednesday. And then we'll go from there. And again, I would recommend probably on Wednesday that you wear some men or a jacket, because I think this room's cold. So have a good day, and we'll see you Wednesday.